So let's first look at our results. What did we find? First, our results lined up with our hypothesis. The dominoes with the taller height of 5 centimeters did fall faster than the shorter dominoes of 3 centimeters. But even the smartest of physicists can be wrong, and we are certainly no exception because when we increased spacing, the velocity surprisingly increased as well. So let's break this down. Starting with our trial holding spacing constant, the average velocity for the shorter dominoes was around 80 centimeters per second, and for taller domino, 90. Then when we kept height constant using the taller dominoes, we found that at 1 centimeter spacing, velocity was around 83. At 2 centimeters, it was around 90. And finally, at 3 centimeter spacing, it was around 95 centimeters per second.
So why did this happen? Ria and Hannah thought long and hard about our misguided presuppositions. What explains these trends? We began exploring some theory on domino velocity. We won't bore you with the details, but here's what you should know about why increasing height increased velocity and increasing spacing increased velocity, even though maybe it should have decreased velocity.
So let's start with height. First, we assume a full transfer of energy from one domino to the next. Based on conservation of energy, this means mgh equals half mv squared. Mass is a constant, so let's cross that out. Rearranging this, we get 2gh equals v squared, or the square root of 2gh equals v. Mathematically then, if we increase height, we should see an increase in velocity.
Okay, but what if we keep height constant and change how far apart the dominoes are? We came across an issue here. Our results were different from what theory says should happen. So, we will first give some predictions for why our ideas about our experiment yielded the results it did, and second, talk about what other and smarter physicists say should happen based on theory. First, why did we find that increasing spacing increased velocity? We think it might come down to the angle of the falling domino. At larger distances between dominoes, the first domino travels a longer angular distance theta before it hits its neighbor. In this time, the free-falling domino is experiencing more time in freefall, gaining acceleration due to gravity, and thus hitting the next domino with a bigger bang, so to speak. Second, once upon a time in 1983, a team led by B. McLaughlin set to work. They found a general relationship between wave speed and a ratio of domino spacing to height. Basically, V over the square root of gravity times height equals some function of distance over height. They looked at 3 variables: height of the domino, h, distance between dominoes, d, and width of the domino, t. So let's look at the graph. If we analyze the graph of d over h and v, experimentally they observed that as d over h approaches t over h, or in other words, the distance between dominoes gets really small, the velocity of the wave gets infinitely large. In relation to our experiment, if height is kept constant, then a decrease in d should result in an increase in v.